Hello and welcome to Introduction to Machine Learning. I'm with ChengCheng and I'm Philippa Burgess. We are both Women Techmaker ambassadors, and this is 1 hour that will potentially change your life and certainly your understanding of machine learning and bring you into this big wide world of really the future that's here, as AI and machine learning are a huge part of where tech is going, and it's impacting pretty much every aspect of our society, and something that not only we should be aware of its impacts, but also be part of understanding how it works and being able to code and create our own machine learning models. And that is what we're going to do here today. And ChengCheng Tan is going to lead us. ChengCheng, you want to introduce yourself?
Sure, yes. I'm ChengCheng, and I work in AI safety using large language models. I've been fascinated with AI for a long time ago. So way back in college, I actually studied linguistics and computer science at UCLA. I was hoping to build these talking computers that could understand human languages, but alas, the time wasn't quite ready yet. So I went on to get my master's in computer science, specializing in HCI, that's human computer interaction, from Stanford. And so I had worked in UI UX for many years, which was actually a ton of fun. But then I took an extended break to homeschool my kids, which was actually even more fun. But now I'm finally back and having fun with AI while still trying to keep it safe. So very honored to be here today and really excited to share an introduction to machine learning with you.
Fantastic. So in my role as a graduate student, I'm your crosstown rival. I'm at USC, and
It's a friendly rivalry.
friendly rivalry. And I did my undergraduate there many years ago, and then I came back to grad school in the pandemic. And really, it was in an urban planning master's, that I absolutely fell in love with data visualization and data science, and then spatial data science, and then that led me to AI and machine learning. And so I am on this learning journey. So today you are going to lead and I'm going to follow, and our audience can also follow along with us. And all of the links to everything we're going to be talking about are in the description. And so check that out and get ready and let's follow along.
Sounds great. So the general plan for today, I'm thinking, is we'll start off by answering, what is machine learning, or ML for short, and how's this different from what you think of traditional programming. Then we'll go through this typical machine learning workflow, which always starts with data. That includes exploring and understanding your data, cleaning it up, making sure it's all prepared and nice, shiny, and pretty, so that we can train that model. And once the data's been prepared, then we'll go on. When the model's trained, then we'll go and start evaluating and testing it out. And then we'll finally sort of go over the next steps, share a bunch of free resources to sort of help you continue your ML journey. Okay, so we'll actually be building a real working ML model today. And so you'll be introduced to lots of tools and resources out there. And so the best thing is most of them are actually absolutely free. So our goal is to give you sort of this basic exposure to the concepts like data cleaning, or training data, models, algorithms, or metrics for evaluation. So you might not become an expert within the next hour, but hopefully this should demystify the process. And hopefully when you go out there to read or search through the resources on your own, you sort of have a good foundation of knowledge. Does that sound good?
That sounds great. I know that when I first was introduced to this course, and maybe it sounds a little bit hyperbole when I'm like, it'll change your life. But I really felt when I saw this, and I was like, wow, this is really accessible and this is really learnable. And that this isn't just something that is out there for others to be part of this truly a revolution, but that we ourselves can look inside and see how these things work and actually program our own model in a very simple yet approachable way. And it's a great starting point for anybody who's had an interest but doesn't really quite know where to start.
Absolutely. That's what we're hoping for. Yes. Okay. So I guess we should just dive right in and let's take a look and start with the basics and look at what is machine learning. right? So if you're familiar at all with the traditional learning, you always write rules in code, right? So like this example, it converts the temperature from Celsius to Fahrenheit. And so the input in a traditional program would be the temperature in Celsius, and then you would use a program that applies this rule or equations or formula and output the temperature in Fahrenheit. Pretty simple, right? So in a machine learning model instead of writing rules, you would actually give it data, sort of just lots and lots of data. So all these are input-output pairs. We give a bunch of input in Celsius and sort of a matching output in Fahrenheit. And the algorithm would actually go through all that data looking for the patterns. And the program isn't given the rules or the equations. Instead, it's the model that kind of learns all the rules and patterns by itself. So you can use this model by giving it new inputs in Celsius that it's never seen, and the model will end up predicting or make an inference to give you the output in Fahrenheit. Okay, and so this, I mean, it feels kind of contrived. It's a pretty simple example because we know the equation, right? But the basic idea is this can be super powerful. I mean, imagine when you have an image recognition program. So what rules would you write to help a computer decide if a photo is a cat or not? You have a sense? I mean, and I think...
As it applies to my field of study, so I'm in human security and geospatial intelligence, and we're looking at a lot of image models. And so as I was asking or having a discussion at a conference with somebody about the applications, they were saying 3 applications. One application is you can categorize things. It can immediately sort of know that's a building, that's a tree, that's a road, there's a categorization. It can also look for change. So it can see that change over time. And then it can make predictions based on what has happened in the past, certain cycles, certain trends, and it can be used in prediction analysis. So that's an example of how it would be used in intelligence or and related to disaster resilience, disaster planning.
Right. And if you have to think of, if you had to write a program to specify every single change to make the classification and prediction, you can imagine it getting pretty complicated if you have to give it every single to come up with all the rules, right? So if you give it lots of data, it turns out it's actually pretty good in figuring it out. In my own field, language is actually the very common one, right? So you think in the past when we started programming, trying to teach computers to understand language, you give it huge vocabularies and a giant list of rules of grammar. And if you think back in high school, I mean, I don't know about you, but memorizing a bunch of rules wasn't the best way for me to learn languages. And so as children, we just get lots of input of what languages sound like. And so that actually ends up turning to be very similar, that if you give a model like tons of good sentences from Wikipedia or books, and voila, you have a model like GPT that ends up learning what language should sound like, what words can go together, and what order, right? So the key difference between this traditional programming and machine learning is instead of giving it the rules, you would give it data. Just data is the key here. And so that brings us to today. We actually get to geek out about penguins just because, well, oh my gosh, penguins are just so cute, right? And so we'll meet our 3 species of penguins today. So we have chin straps, which are these little guys. You actually see under the chin, there's that little strap. And then the gentoos have these beautiful beaks and this orange beak and patterns on their eyes. And then the adelies have these completely dark heads. So before we dive in, it's always important to really just understand the data that we're dealing with. You want to understand, so where did it come from? Who collected it? Why? What are their motivations? Then you'll want to understand sort of the data type that you're looking at. Are we looking at photos, numbers, words, whatnot? And then what kinds of questions this data can answer. Okay?
That all makes sense. Exciting.
Great. Yeah. I mean, who doesn't love penguins, right? So these penguins, they come from Antarctica. They're near the South Pole. Ours are from Palmer Archipelago. So it's this group of islands here off the peninsula, specifically 3 islands called Turgeson, Dream Island, and Biscoe. And so penguins tend to kind of live in these colonies of a bunch of the same species. And we can see here that all the Gen 2 penguins that were collected were found on Biscoe Island, and then the chin straps were all found on Biscoe Island, Dream Island, sorry. And then Adelies were actually found on all 3 of these islands. So you see, they're trying to color code the islands
it's very clear. I love it. It's it's a great way to present it. And here we are. We can play with data. We can make visualizations. This is where I first fell in love with this path that I'm on, was actually seeing data visualizations and saying, wow, I really hadn't thought about that and how powerful they are. And then once you begin this journey, you realize how much there is to learn, but exciting. And it's a fun journey with an amazing community.
Yeah, the visualization, I think it really just helps bring the data to life. And so that's actually one of the undergraduate projects that got me into first playing with data as well. So totally. And as adorable as our penguins are, so we need to understand that our data is actually not photos or images. So it actually comes in tabular form, which just means that they're tables with rows and columns like a spreadsheet with information about each of our penguins. And so these include, hopefully it's pretty straightforward. There's the bill depth, the bill length, flipper length, body mass, and so whether it's male or female. And so you can actually search for the words Palmer penguins and find plenty more yummy tidbits about our penguins. But so the idea is after you have a decent sense of your data, sort of the distribution and what types they are, it's got to get all prepped and ready for the model. So between collecting and wrangling the data, just dealing with your data in general, often takes like 80% of the time in a machine learning project. And that's mind-blowing, but it's actually insanely and true, unfortunately. So data is a big part here. Okay. And so for our input, we'll actually be using features or characteristics of each penguin, like the info about the bill or the flipper sex and all that good stuff. So you'll want to check for like the missing data and figure out what to do in those cases. Like, do you want to fill in some default values or get rid of them entirely? And you need to also know that computers prefer data to be in numbers. So there's lots of pre-processing involved there. And our example here is something called supervised learning, which means that the output of our model will be labels, or these are also called targets of what you're trying to predict. And this will be sort of the class or the species of penguins, whether it's Adelie, Gen 2, or chinstrap. And so again, computers will always want numbers, and if you're familiar with programming at all, they always count from 0. So we'll assign them in classes where 0 will be Adelie, and 1 will be the Gen 2, and 2 will be chinstraps. And the next thing that we'll need to do is we'll be splitting our data into a training set and a test set. And the 80-20 is a pretty common way to split the data, but some people have other preferences. So that means, like, for example, if we have 100 samples, we'd train our model on only the first 80, not necessarily first, but at least 80 of the samples, and afterwards evaluate how well the model performs on the remaining 20. So it's actually really important that you never train on all of your data, because you want to hold out some random sample that you can evaluate later.
Yeah, I've definitely heard 80-20, 70-30, sort of in that. People have different preferences, but definitely that's the standard.
Right, yeah. And if you have millions and millions of data, you don't necessarily even need 20. You just need enough to, you can get by with even like 5 or 10%, as long as you have enough to test how well your model does. So there's a lot of flexibility, but the important thing is you need to hold out part of it. Yep. And it's also important that it's a random sample, so that the training and testing should have similar distribution, right? You don't want everything all clumped together. You don't want to train on all the Adelies and then test on all the chin straps. I mean, that's not going to be very useful there. Okay. And the great thing is there are handy libraries that are already existing that will split and take care of all these things for you.
Fantastic. Okay.
Yeah, so now we get to move into models and algorithm, right? So how is our computer program going to figure out which of these cuties are which ones, right? So that's where our models and algorithms come in. And the decision tree is an algorithm that's actually fairly easy to follow if you're new to machine learning. So you can kind of think of it as a flow chart to make decisions based on the data. And the model can use these input features to learn how to predict the output labels, right? So the output would identify the class of penguins is, given your input of the characteristics. So like this example here, if we're given a bunch of features of a penguin, we'll take a look. Is the bill length less than 44 millimeters? If yes, then we've got an Adelie. If it's not, then we'll ask the next question. Is this on the island of Bisco? If yes, then it's going to be class Gen 2. If no, then we've got a chin strap. So does that kind of make sense? I mean, hopefully
That makes perfect sense. Yep. It basically, another word that I've learned in my journey is Boolean. So it's Boolean logic, which is Boolean is a yes or no, or true or false, A or B. And so this is just very simple. Is it this or is it this? And then once you have a no, then you can ask the next question. Is it this or is it this? And that's until you get to the conclusion. So with the yes, we already got to our conclusion. With the no, we still have more questions to ask.
And sometimes even yes, you can ask multiple questions. And sometimes in this case, it's a binary tree. There are some cases where it can have multiple branches into more than two yes, no answers. But in this particular case.
Yeah, it's a very simple. We get to yes, we've got our answer. We get to no, we still have one more question to go.
Right. So ideal, intuitively, it should be good for humans to understand at least. And so that was a single tree, but what we're actually going to do is use a decision forest. And so just like a forest is a bunch of trees, a decision forest is another algorithm that uses a bunch of decision trees as building blocks, right? So we saw one way to build a decision tree, but really there's zillions of ways, right? You can use different features, use different values. And if you train on, depending on which subset of data that you use, the optimal tree will be different in each case. So what you can do is you can take all of these bunches of trees, right, and kind of pull them if you give them all the same input feature and ask them each to predict what they think the correct output should be, and then just sort of have a majority vote wins. That actually turns out to be far more accurate than any individual tree can do, because it seems that each tree on its own has errors and biases, but as a whole ensemble, sort of in aggregate, they tend to cancel each other out and achieve sort of a better accuracy, which I always found that to be a really cool idea.
Oh, very much so. Oh, I'm excited. What's next?
Yeah. So, we'll get to see, but the amazing thing is that all the code and math behind all these decision trees and forests, and actually most of ML, is they're part of existing libraries. So you actually only just call a few functions and pass in your data, and we're pretty much standing on the shoulder of giants. So that means we can focus on the fun stuff, whether it's the geospatial data or language or whatever else you're interested in. So,
and just to be clear, we're going through this now, but we're actually, I guess we're answering my question. We're going to see this code in action.
Yes, we are going to jump into code. So here is the link here on the screen, but I presume you'll also post it somewhere else.
It'll be the description.
Yeah, so you'll be able to follow along. So this is so we've got sort of the overview of the concepts, and the code here, if you click on this link, will bring you to a Google Collab notebook here. And so if you've never used a notebook before, you might be wondering, well, what the heck is this? So it's essentially a coding environment, kind of like Google Docs for Python, that runs right in your browser. And it's really great for learning and testing out little snippets of code. And you don't have to install anything on your own computer. And whatever we run, if you run the same code, you should see exactly the same thing and get the same results. So I'll scroll down a little bit as you see. A lot of this should look familiar. It's kind of what we just talked about. And so you can feel free to go back here and review things as needed. And you'll see there's these little triangles that you can click to sort of expand and collapse the different parts. So and the idea is these notebooks, right, they contain cells, which can have either text or they have code sections. So if you double click on one of the text section, you can see that it's in markdown format, if you're familiar with that. So there's quite a bit of documentation in this notebook so that you can use it as a reference even after we're done today. But all the extra text I find is a little distracting for the demo. So for this purpose, I'm actually going to switch to another notebook, which allows us to just focus on the code. So functionally, the link that you clicked and both notebooks are exactly the same as far as code is concerned. So you can stay in that notebook if you'd like. And I'll just show you to run the code. You can click on this little play button, or command shortcuts would be command return or control enter on the PC. And so this will actually start downloading stuff. So you see this little spinning thing. It tells you it's working hard. You'll need to explicitly run each code cell, even though you see everything from top to bottom. But if you skip a cell or don't run it in order, it runs it exactly in the order that you execute things. So it's probably best to go in order. If you jump around, it can get a little confusing. So yeah, generally you'll do it sequentially.
So I have two things to add to this. One is when I first started learning Python,
Mhm.
I was so confused about the interpreter. And I was so excited to learn about Collab because actually you don't even need to have Python downloaded on your computer to use this.
Mhm.
And it was such a simple template, like exactly what you said. It's Google Sheets, it's the same thing. And so if you're just starting out, Collab is such a great thing to know about. It's so easy to use because that was actually my sticking point when I very first started my Python journey was, wait, where do I start? What interpreter do I use? And then later I got into PyCharm, and I'm still kind of working my way through. I'm actually in class this semester with a Python customization for GIS course. So I'm going to get much better at my Python coding skills. And I'm very excited for that. And the other thing is, in a previous class when I was learning RStudio, we were presented with something that was this simple, and I overthought it and thought I needed to be writing in code. And I actually learned a lot because I overwrote it. But I had to go to my professor for help, being like, hey, I'm confused here. And he was like, no, all you needed to do was just hit run and then hit run and then hit run. So it is a lot simpler than trying to think that you see a prompt and then you're supposed to write something in that prompt. Your task is to run it. And then we'll go through what happens when you run it. What does the computer do and what's next? And if there is something where we're supposed to write something, we'll get very clear instructions on what to do there. But at this point, your task is to read a section and then just click run. And then that will pop up and then lead you to what's next.
Exactly. You're actually not, you don't actually need to code anything. So think of this as a template of something that's already working, and then you kind of just copy and paste your specific, if you want to try and change different things. So it's really a great introductory way to learn things. And I know the same thing when I teach Python in the past. You always spend like the first week, everyone's like, this doesn't work on my computer, or I'm getting this error, and just trying to figure out all the details of how everyone's computer is a little different. It's a huge headache, and here you get to just focus on the fun stuff. So.
Yes.
Yeah, so now that it's run a bit, I just wanted to point out a few things. This little green check mark here tells you that this cell has been run, and the little number next to it tells you this was the one, tells you it was the first step that was run. Here's the second step, right? The third step, fourth steps. And so if I ran this again, you'll see that this number goes to 5. And then if I run it again, it'll bump up to 6. So in case you run things around, if you don't see a check mark, it means you didn't run it. If the numbers are out of order, then rethink, make sure things are run in order that it should be. Okay. So let's take a look. So by default, as we mentioned, it is running Python code in each one of these. And so if you see a little exclamation point, that actually means it's a command line instruction. So it runs it in the shell. So it's not actually, this first one wasn't Python. It's actually just installing the library for the TensorFlow decision forest that we mentioned mentioned before, and we'll use it as TFDF here. And then there's some other common, we'll import some other common libraries that's used for ML problems. These are all free and many of them are open sourced, right? So NumPy here is for linear algebra, doing a lot of these matrix calculations. Pandas is a data frame for tables with rows and columns. And then TensorFlow, it handles many of the common machine learning tasks. Okay. And then our next step, so now that our environment's all set up, we'll get to start loading the data. So I'm just going to run them through because sometimes this takes a little while, jumping the gun a little bit. Okay. And so we get the data. Again, the machine learning is all about data, right? It seems counterintuitive, but most of the time really in building machine learning models is spent collecting and wrangling all that data, because the quality of your model's input has a huge impact on the output. So we really need to understand the trends and the patterns in our data to better understand where our output's coming from. So we can't really just blindly trust that the output is truth in some way. So if there's any bias or skew in all that data, that's going to impact your output too. And in our case, our data set isn't too large. It's about 300 entries, 300 penguins here. So we'll get it from a CSV file, that's comma separated values. And so PD is the pandas data frame. The pandas library will read in the CSV and store it in a data frame, or DF for short. And so if your data set is really large, like over 1 million entries, you might want to use a different class, like a TensorFlow data set instead, but this will work for our case. So we can take a look at what we have here. You can see the data frame is tabular data. So we have tables with rows and columns describing each of our penguins. So the first column here is the species, and this will be the labels that the models should learn, given all of these other features like the island, the bills, the flipper, body mass, sex, and year. Right? So the year, you see it's all 200. So that's actually when the data was collected. So I mean, that's probably good record keeping, but probably not super helpful in trying to predict what species of penguin you have there. And also notice that we have some NaNs, which is not a number. So these are kind of null values for whatever reason. And we should see this because of DF head. So the data frame, it's showing the first 5 rows. You can actually change this. So this is an example of something that you can play around with. If you do DF tail, it will show you the last 5. So now it's a bunch of chin straps from Dream Island, right? So you kind of see the species and the islands are all clumped together. So we'll definitely want to shuffle this up later on to make sure we have a nice even distribution throughout our training and test data. And then if you call this DF by itself, it will actually show the entire, so just plain DF will show the entire data frame, which is a little too much to show all at once. So we see just the first few and the last few data. And so we see there's a total of 344 rows and 8 columns.
And you bring up a really good point on the null value versus 0, because it's one thing to say 0 we don't know versus, but if it's elevation and you have all these, that it's going to average it out to something that's not actually correct. So I know in geospatial, we're often really coached to make sure to include null as often as possible, because null means we not available versus we're putting a 0 in where that's really truly an incorrect number and is actually going to hurt your accuracy of your ultimate end result. So that is something that has to be discussed with a team or whoever's collecting the data, cleaning the data, how you want to actually deal with missing values. It's a huge challenge. And there are a lot of data sets out there where they just did input 0 instead of null. And so you need to be aware of that.
Yes, definitely. Yeah. Or someone might decide to use like -1 as a placeholder, which could mean something completely different. So yeah, definitely understanding your data and seeing how it was collected and how they managed it is definitely important.
And we're also in this new semester in the new Python course, our professor right now is saying, I'm giving you clean data to run these exercises with. But as the semester goes on, I'm going to task you with doing more cleaning of your own data because I want you to really be prepared for the real world and how messy data really is.
Exactly. Like they said, you spend most of your life cleaning up data. So having clean data is actually very precious because that rarely happens in the real world.
Yeah, she's made us understand, appreciate, and respect that.
Yes, it's golden. Yeah. So in continuing our data exploration here a little bit more. So there are libraries in Pandas and TensorFlow that have these summary statistics like count. So I'm just gonna, actually it looks like they're run through. So you can run through those and you can see like this group by. So you can group by the species and just count how many of each species. So we see here that, Adeles and Gentoos have over 100, whereas we have much fewer chin straps in 68 sort of, and then you look across the board, it's pretty complete. All the chin straps have the same number of entries for all the different features, but if you look at the Adeles, right, not all of them have the same values, and the sex for Gentoo and Adeles are seems like it's much less complete, so there's probably some missing data there. And so looking down here, we group by the species, but now we're looking at the mean of each of the columns. So looking at the average body mass, for example, in the Gentoos, it seems like it's much higher than the average body masses for the other two genders. And so what else would we want to say here? Oh, and you notice that we've lost a few of the columns, right? There's no island or sex when it comes to mean because they're probably strings. So average of strings, it's pretty much gibberish. So they kind of just dropped it here. It's been ignored. And I don't know about you, but looking at a sea of numbers is kind of hard for me to figure out heads or tails out of things. So bar charts are usually quite helpful for you to sort of spot patterns. So you can really see the Gentoo is much larger in body mass, and the year you're seeing it across. So it looks like it's been collected across just a few short years. And so down here, then we have something that called the data frame iLock. If you pass it 0, it pulls up the details of row 0. So that's sort of the first Adelie penguin that we have from Turgeson, and then we see all the specs. So if you want to look at specific data, you can give it different indices to look at specific information about each of your penguins. And then DF info is a really handy function that you can call that gives you an overall information of the entire data frame. So it lists all the different data types for each of your columns. As you'd expect, all the dimensions of the flipper and the bills are in numbers or floats.
And let's kind of just, we can look at that for just a second. So because again, I'm studying what we're learning. So float is a number that's going to have a decimal point to it.
Correct. A floating
and then
point.
An integer is a whole number.
Correct.
And an object is an item we do sort of object-oriented programming, and geospatial is very object-oriented. It's the object.
Right. And so it just means it's not some primitive structure. So in this case, for the species and island, this object probably is just string, but it's possible that it could be something more complicated. But in this case, they're probably just strings. Okay.
But it would be strings of text.
Strings of text, correct.
Yeah.
Strings of strings of text. So it would be like an array of characters. So that's why it's not one simple thing. And so the other thing that we want to notice here is we have 344 rows, but some of them only have like 342 and non-null entries, and the sex has only 333. So you might kind of imagine, actually sometimes it's hard to tell for certain types of penguins just by looking if it's male or female. Or maybe you can imagine some poor biologist, running around with a tape measure and getting distracted by all those cute penguins. But for whatever reason, we've got some missing data. So who knows, right? So how are we going to deal with that? And so part of the data cleaning, so fortunately, we're not missing too many values. So it's about 11 between 344 and 333. So what we can do here, again, I'll just run through these real quick, is drop NA. We'll drop those 11 null values. And that will allow us to make sure all of our data is valid. But you really want to be careful. Sometimes dropping values, you might be excluding large swaths of your data, which leads to other problems and biases. So in this case, it's okay, but you really need to understand what you're doing and specifics of your data before doing that. And the year was another thing we talked about before. It's great for record keeping, but probably not super helpful for our model. So we will drop that column as well to exclude it. And so if we look at the info now, it looks nice, looks a little better. And so what we'll do, so we see it's all 333, and then we don't have the year anymore. And so that, what we'll do is we'll take this, let me see if I ran it. So we'll take our nice clean data and replace it with our original data frame. So we'll be working from this moving forward. And so that took care of all of our input features, but our labels with the species will need some love too. And so there's currently strings, which indicate the categories, right? Whether they're Adelie, Gen 2, or Chinstrap. But the model really wants to work with numbers. So we'll need to convert each of these class we'll convert 0 for Adelies, 1 for Gen 2, and 2 for Chinstrap. And so this code handles that. Then the other thing we'll need to do, if you remember, we had discussed our 80-20 split with the training and testing data set. So again, luckily NumPy library has these handy functions that will help us randomly shuffle and split the data for us. And so finally, we'll also convert our pandas data frame to a TensorFlow data set. And so now we'll have 261 samples in our training set and 72 examples for our testing.
I love it.
Love it. So get to the exciting part finally, hopefully, maybe. So it's actually, gosh, how far are we? We're probably been going on for a while, well over halfway through our hour, and we haven't even touched a model yet. So you might be thinking, training a model, it sounds like hard work at a gym or something, or at least some like mind warping math. But ironically, this is actually one of the easiest part, thanks to all those ML libraries out there. It's actually just 2 lines of code here, right? So you call one line to create a random forest, and then fit actually does the training. You pass it in your training data, and we're actually all done already. And so just a couple quick notes here. Verbose here. So random forest is actually one of many models in the TensorFlow Keras library, and the verbose option here, it's a number. You can pass it 0, 1, or 2, and it just tells you how much information it's going to spit out while it's training. And I also passed it a random seed here, so that way it controls our testing, so we always get the same results every time we run it. But normally you might not necessarily want that. But oh my gosh, we're done. So models all trained, and so our next step is we're going to be evaluating. Let's run through some of this code. And so evaluating is always pretty exciting, I find. So we remember that 20-80 split, right? So our model was trained on 80% of the entire data set. So now we'll get to see how well it performs on that remaining 20%. And TensorFlow library has these methods. So we give it we're going to measure how well it does using the metrics of accuracy. So how, did it actually return the right class that we want? And so we have a 97% accuracy, which this is unusually high. This is it's our little toy data set. So you rarely see anything this awesome in the real world, but it's nice to start off with that. So
in the real world, what would be kind of a more
it really
normal?
Yeah, I think it really depends on each data set. It is different, but in the high 90s is definitely. I mean, if you get things.
I was gonna say, should be like over 50% or kind of over 60, over 70? Is there sort of a norm of sort of where you want to be?
It totally depends on human accuracy, what kind of things that you're doing. So there really isn't a right or wrong. It really depends. I mean, there are certain things where 50% in a language model is pretty good. If even humans are only getting like 70%, but if there's things that for like image data, when they started getting 80%, 80-90%, that was pretty good. I think like AlphaFold at one point, I don't remember the exact name, 80-85, they considered that to be like supremely good. So it varies a lot depending on the specific data set. And 50% would be considered horrible if you're just predicting two classes, right? Because that means it's as good as random chance. So it really just depends on the data set. And also accuracy may not always be the best measurement of a metric as well. So if you imagine you're trying to predict if a number is between 1 to 10, right? And if you're given inputs of trying to predict a digit between 1 to 10, and you're just predicting, is it a 5 or not? And most of the time, 9 out of 10 times, it's probably not a 5. So if you just always guess that you have a 5, you're going to be like 90% right. So that's a high accuracy, but that's also not very meaningful. So it varies a lot on the metric and the data that you have.
Which sounds like the two things, going back to be familiar with your data, like the more you know your data, and context of your field, your study, the questions that you're asking and looking to get answers for. So having a greater context around why you're studying it and what you're looking to create will give you a better understanding of how well you're doing relative to your specific data and question and problem. And I think that in my little creative project with Bard, we wrote a play together. But I was so clear about the time frame, the characters, it was based on history. So if I hadn't known that, it would not have been as great a collaboration. So I was able to coach it because I kept reminding it of different characters and didn't always get the time frame right. It doesn't always get the facts right, but it was still a very creative, and we had a lot of fun together. But I think that context is really key.
Right. And you can imagine if you're dealing with health data or people's lives, or you're filtering videos for children, there are certain things where your expectations of what is a appropriate accuracy would be very different from something else if you're trying to recommend a system. If you make a poor recommendation that someone didn't like, the risks are far lower than predicting, telling someone they have cancer or missing a cancer diagnosis. So it all definitely depends on the context.
Absolutely. But it's really exciting that they're able to bring this type of machine learning into, they're bringing it into physicians' assistant offices. I know they're bringing it into radiology so that it can actually help them diagnose, what is that x-ray? And obviously the technician, the radiologist, the doctors have experience, but now they get to supplement that with what the machine learning model can also tell them.
Yep, absolutely. Yeah, and the exciting thing I think about the radiology is the image recognition. They find they're almost as good, if not better, than many humans at detecting the tumors and things. So there's definitely a lot of exciting potential out there.
Yeah. Yeah, this is being so widely deployed in our society, and I've read it, the headlines many times. Like, this is the new revolution, and this is an exciting time to be in it, to be part of it. Things that were very exciting for me that I didn't really even comprehend is when I watched a lot of the videos that are now available at io.google for the Google I/O conference, really saying, hey, developers, here's the API, go build on our technologies. And so there's a really wide open field for people to bring their innovation, their creativity, and build on much of this technology that's already been created. And
exactly, right. The pre-trained models and the APIs that you're not having to build everything from scratch. You really are standing on the shoulders of giants, and they're just trying to make things, much easier. It really helps the whole landscape of approaching this, that all our creativities and diverse inputs, and seeing how we can all solve different problems together.
I love that. Okay, so let's talk about plotting the model.
Yes. So you might actually often hear that models are these black boxes. You kind of get a result and have no idea of the how or why behind things. So the nice thing about decision trees and forests is that you can actually dig into the details and see what's exactly going on. So up here is just a quick reminder that we have a deli is 0 and 1 is Gen 2 and 2 is chin straps. And so by default, when you run the random forest, the number of trees that they use in the forest is going to be 300. And so you can actually plot any of the trees and see what's going on. So for example, here, I'm just picking tree number 50 and we can inspect it. Some trees can get a little deep, so I'm going to set the max depth to be 5. And this is actually the tree. It looks a little similar to that vertical tree that we saw before, but instead of reading it top to bottom, we read it from left to right. And so in addition to seeing the class numbers, they've kind of color coded it for us. So the 0 is going to be a deli is red, and the Gen 2 is blue, and chin strap is green. This is class 2 here. So we'll kind of dig through each one. So how we read this chart here is that we started off with 261 penguins in our training set. And so the first decision that we ask is, was the bill length greater than or equal to 42.4 millimeters? And so if it's yes, you follow the green line. And so of that group, 100, we have like 150 penguins here. And so most of them seem to be blue. And then we've got a few greens and a little more green, some greens, and then just a handful of reds here. And so the next question that we'll ask here is the island come from Dream or Turgeson? And so if yes, then we'll go down and we'll find the 60 penguins here. So it looks like at this point, we've filtered them out to be mostly the green chin straps and just a handful of the red adeles. And so depending on the body mass or the bill length, we'll find that most of them are going to be the green chin straps, and then just like 5 of them are the adeles. And so we'll kind of traverse our way back up to the tree here. So if the decision, if it wasn't on the Dream or Turgeson Island, that means it must have been Bisco. So then most likely it's one of these 90, probably one of the blue penguins, even though there might be like a handful of them that are the red adeles. And then if you go all the way back up, our original decision here was at the very top was the bill length. If it was less than 42.4 millimeters, then it might be one of these 111 penguins that are red. That's class 0 adeles, or it might be a couple of the blue ones. So the idea is each of these end tree nodes are the predictions. So in theory, you would, if in the ideal world, these are all the greens, all the reds, all the blues. And when we see kind of the mix of colors, it tells us that there was probably some misclassification involved. So that's kind of how you would read it. Is that enough? Would you like to try reading a tree? Or we'll save it for another
well,
time?
I'm just I guess my questions are, so it's taking this data and then it's figuring out, it's the same thing. It's like, is it yes or no this? And then it kind of classifies them. And then it gets the next question, yes or no. And then it classifies yes or no. And it classifies. And so, yeah, so that it's kind of figuring out based on that bill length, based on that height, weight, which of the species is this. So yeah, that makes sense to me.
But the key is it's the machine learning model that had decided which features to use and which values to use. So it decided how to build the tree. Just wanted to make sure that was clear.
Yeah, these were not, like, we could have in a different setup said, if it's this less than 42, but we didn't do that. We just said, you figure it out, you go.
Exactly. So if you just randomly hit another one, it shows you a different tree that it built. It uses different features, different values, and it would have different accuracy. So
this is very customizable.
It is. Right.
So one of the things our professor is saying to us is that we should be practicing writing our code. She actually says, please don't just copy and paste. So I would say if you're a beginner, great. And at anybody level, if you're just seeing this for the first time, follow the instructions, hit run, follow along. If you're a little bit more advanced and you're taking this to the next level, go ahead and change the values and practice and try different things. And if you really, really want to take it to the next level, go ahead and open your own brand new Collab page and split your screen so that you have this on one side and your blank Collab page, and write out the code. Write it from top to bottom, and you will have just such a deeper understanding and an even deeper learning of this to really start making it your own. And if you want, go ahead and comment out those things with those double hashtags so you can make your notes about what each of the code actually does, what your process and process is, so that, and you could share that with someone else and they'll actually know how to read your code as well, because you've given your instructions of what's happening here. So that you really are saying, hey, I love this, and but I really want to make it my own. That's the exercise, is make sure you go beyond cutting and pasting and start writing it yourself.
Absolutely right. That's critical in learning, is to make it your own. You see you learn from other people's code, but then you want to build it up and make it your own and swap out different things to your specific data and trying different parameters. So absolutely.
Yeah, that's how we're learning. And I also, similar to something, I think this was in an earlier conversation we'd had, I don't learn by rote memorization. And I think you made a comment to that too. I learn by practicing. I learn by reading, writing, conversations, trial and error, doing things. And but the clearer the instructions are, the better I'm going to learn. And I've learned to avoid too much of the error part of trial and error. So when somebody can really give it to you this clean and this step by step, and then to be able to make it your own, you're going to go further faster.
Hopefully, yes. Definitely, yeah. Okay, so then the next step here is we can also plot this is some code to plot the number of trees in the forest and see how they affect the accuracy and log loss. So I'd mentioned the default number of trees, and there's 300. And so the accuracy, we can see it's running from 94% up. So these are all just pretty good in general. But the log loss is actually sort of the opposite. It's measuring, it's a measurement of error. So for good performance, you want high accuracy, but low loss. And so you can kind of see that it looks like around 50 trees or so, it's kind of flattens it out. And whereas actually this one looks a little different from what I was looking earlier. It's a little more jaggy, but you can also see like from 50 trees and above, your accuracy tends to flatten out a bit too. So that's kind of a hint that maybe you don't need the full 300 trees. Around 50 or 60 might be good enough. In our case, the training was pretty quick. So, but if you had like millions and rows of data and it took weeks or months, this is something that you might be able to optimize for to get decent results in a shorter time here. And then TensorBoard is another tool that's kind of fun to look at. We'll just take a quick look. It's a free tool from TensorFlow, and sometimes it takes a little while to show up, but it's another way that you can kind of just another way to visualize your data of your accuracy and sort of your loss there. Okay, and so we kind of took. So feel free to go play around with some of those. And so what's next now that we've trained and evaluated our model? So we've talked about before, there's plenty of things that you can kind of just tinker around with just to explore and see how things work. And so we had mentioned that Keras has many other models besides random forest. So these other choices that you can do gradient boosted trees or CART model, distributed gradient boost trees. And so here's an example that we can try with a gradient boosted tree. You can also try just doing a subset of the features instead of using all the features. Here they're just using the bill length and the island. And so you can actually hold your cursor over some, a cool thing about this Collab is if you hold your cursor over any of these functions, it gives you all of the different options, the parameters that you have. It's kind of a lot. So anyway, you can go read the documentation. I think you'll be able to search for them and just play around with these things. So we'll use the same training data and the test data that we had before. And if you see here, it actually, accuracy goes up a little bit to 98%, and it seems a little, why would this be? We're using the exact same data. We're using a tree still, and we're actually using less features. And so there's just different things that you won't know until you experiment, and different algorithms will have different results. So it's just part of the learning process. So try different things, compare the results, and there you have it, folks. I mean, you've gone through the whole entire sample ML workflow from data to training and evaluating models. And so that's essentially the foundation of machine learning. So, woohoo!
And then we did it in under an hour.
Yeah, did we just hit an hour, a couple minutes short? So before we go, we can say the fun's just begun though. So down below here, we are some of our favorite resources for you to dive deeper. So all of these are absolutely free. There's video courses, more tutorials, and Collab notebooks like this. There's tons of free data sets to explore. And I mean, in fact, many times you don't even need to train your own models from scratch. There's plenty of existing models that you can just use off the shelf. TensorFlow JS, it has a bunch of models that can just be plugged into web applications. Kaggle is this neat community with competitions for you to practice solving real problems, and they have this titanic data set, which is considered the hello world for machine learning. But most importantly, I think we'll just re-emphasize that you can build and play with the kinds of data that you're passionate about, right? So customize it to geospatial things, clothes, recipes, I mean, you name it, whatever you're into. And so the best way to learn is by personalizing these projects for yourself or for your own work. And so we hope that you can use this as an inspiration or a stepping stone to continue your journey in ML. And a huge thank you for joining us today. And we really need more people contributing to AI and ML with diverse backgrounds. So need your fresh ideas, and super excited to see what else you build.
Yes. And with that, I'm going to say a big part of my learning journey has been building relationships and within communities. And so, as you're watching these videos or learning or just joining Facebook groups or just commenting and being part of community is a great way to make that learning exponential. And that there's a lot of, I think, coding that's done by yourself, but there's a lot that you build on others, you collaborate with others. You can join a local GDG group which is Google developer groups. There are throughout the country and throughout the world. Women, please come, and allies, please come join us at Women Techmakers. You can become a member with your email. And my channel is here to grow and build a community. So just all sorts of ways that you can not just have the initiative and the inspiration to do this on your own, but do this and make new friendships and build and find opportunities that will take you further faster. And with that, I thank ChengCheng Tan for joining us today. That was wonderful. I am so inspired, and I look forward to everybody here being inspired as well.
Well, thank you for the opportunity.